but I promise I'll make this really, really boring as well. So what I'm going to be talking about is a lot of the work that we do within the AI space, which is figuring out how do we put these things into production in corporate environments. How many people here have tried that? How many people have tried actually working with prompts within corporate environments and work? Okay. So in our simple view, the big problem that we're dealing with here is stochasticity, which is just a fancy word for randomness. And in our, again, very simple view, we don't have an NVIDIA budget, so we're not going to deal with the problem of model stochasticity in the model itself, but we're going to try to deal with it in terms of the output. So we try to we think of it in two ways. First of all, stochasticity comes from the context. Typically, when you prompt things, you use natural language. It's extremely ambiguous. It can, one word can mean many different things. And every time that you use a word and you don't properly define it, you're basically letting the model randomly to choose one of those interpretations. Second of all, it's the execution decomposition. So what I mean by that is that when you ask the model, for example, very simple example, give me the answer of 1 + 1 × 2, right? There are 2 steps. In most of the prompts that you give one of these models, there are an implicit number of steps. And due to the ambiguity in the language, it also means that the possible sample space, let's say, of the solutions, or the possible solution space is really, really big. So, next up, slide. There we go. So what I just described before, in a very, very simple way, or in a chart, is that the solution space grows the more ambiguous you are in terms of context, right? And also in terms of I'm calling it the steps in terms of how you execute, but in reality, it's the path of execution to solve the problem that you're giving the prompt. Next. So within this entire solution space, every time you run this prompt, you're going to be jumping around, and it's going to give you different solutions, which just does not work in a corporate environment because you want to have real solutions to real problems, right? So next step. So what we do is first of all specify context. That's where RAG comes in. The more specific you are with regards to what you want to have done, the better it is, or the easier it is for the model to actually choose which path it's going to go by and then give you a proper answer. In this case, the way that we think of language models is that they're really, really good reasoning engines. I know that many people here would say, oh, they're actually not that good at reasoning, but just bear with me. They're good in a sense that they understand natural language. So if you basically give it a book and you say, can you please find this information within the book and have some simple reasoning, then it'll actually do it quite well. It'll actually give you different answers if you do that, versus ask it exactly the same question without referencing the book, even if GPT has been trained on that book. And the way I see it, it's that it's very much like a human being. If you went to school and you learned where capitals of the world were, you're kind of guessing. You kind of remember where they were, but you don't know exactly where that source came from, so you might get it wrong. On the other hand, if you give a person a book, then they will figure out how to look into the book and they'll give you the proper answer. Same thing with specifying the context, which is why a big context window is really, really important. Next one, please. If you also specify the steps in the prompt, you're basically reducing everything from the solution space being this big to this being the one, and I didn't mention it in the past slide, with regards to context, to also specifying the solution space based on the actual steps to solve the problem. So here you're going both in terms of context and in terms of the prompt decomposition. Next step. And the way that we've done that is by something that we call semantic programming. I know that the term is used in different contexts, means different things. What that means for us is that we use a combination, let's say, of more strict deterministic software programming together with natural language programming or prompting. And the reason why we do that is because we want to be able to give more specificity in terms of the path of execution for the problems that we're actually trying to solve. And to do so, we are using a declarative DSL or a language based off YAML so that it's kind of legible by people. You don't need to be a super coder to be able to deal with this thing, but you're able to specify many things. So first of all, we're able to specify things like context, thread, SIKE. This is the basis for SIKE, deals very much in terms of threads and context windows similar to ChatGPT. So here we're just specifying where we want the output of this prompt execution to be stored. We're also able to specify the foundation model. In this case, it's GPT-4, and also if we want to take into account history in the chat, right, or in that context window. So we're saying the 5 latest conversations in that specific chat. But now, more importantly, we're also able to specify the prompt. If we want to have a RAG module that is linked to that prompt, and in that case, we have preloaded a specific knowledge base with files so that it's easily accessible to people that are actually executing these prompts. In the corporate sense, we've also added, or rather for corporate compliance, we've also added permissioning, which means that once you have defined a RAG module and you've added sensitive information to that, then only people that have logged in with the right permissions are actually able to execute prompts linked to the information in that RAG module. And then temperature and actual instruction. So in this case, we are dealing with extracting information from a specific RAG or a combination of RAG modules in this case, actually. And then once that output comes out, then we're translating it to Swedish, and then we are formatting in terms of Markdown. So you know every time this pipeline gets executed, this is exactly what's happening. Next slide, please. Yeah, let's go to the next slide because I always spoke about that. Okay, so here I'm showing you a little bit more in detail how you can daisy chain the execution of that prompt, which is actually really, really important because this is where you actually define the execution steps once you've defined the actual context that you want to run the prompt on. So first prompt, what is 1 + 1? Second prompt, multiply the output of the first prompt by 2. Third prompt, divide the second prompt by the value of the first prompt, which in this case is 2. So here you can see that you can have a really, really deterministic path of execution for natural language processing, which is extremely important. For example, if you're going to be studying, or if you're going to be writing an agent or a set of prompts that, for example, is going to correlate a news article with a company, right? That sounds, in very simple terms, like you just take the news article, you put it on the prompt, and you say, well, correlate this to this specific company. ChatGPT is probably going to give you an answer. Question is just how good is that answer? Now, what you would want to do is actually create a sequence of these prompts where you take first the article and you extract the top 10 topics. You take the second prompt, takes those top 10 topics and tries to extract relevant information about the company that you're trying to study. Then you do an analysis of correlation, and then finally you may want to be doing a forecast or a scenario analysis on all of that information. The output is going to be much, much richer. There's going to be references. There's going to be a way in which you can question why the outcome is the way it is, as opposed to if you just put that into a straight prompt into something like a GPT, or let me be more clear, instead of just putting that big prompt directly into a foundation model. Next. Apart from what I just went through, which is effectively the core of how SIKE works, we've also added a bunch of different additional features that make the system corporate friendly. One of those is the concept of a microsignature. Now, we personally don't really care if the outcome of a GPT model is from a GPT model or is from a person, as long as an individual has actually signed off on the validity of that information. So when we build these workflows for corporates like healthcare companies and so forth, what we do is that we build in this specific little feature so that once an output of certain validity has been generated by one of the workflows that the person defines, they can microsign it, which effectively means that they attest and they sign on to the validity of that information, and that gets put into a blockchain-enabled log so that it becomes an immutable ledger, let's say, of things that people have signed on to. Therefore, you're on the hook for signing on to things that are actually not true. So it's on you to actually check if it's real or not. Next one. The second part, which I think that many people are actually struggling with, is how do you build business models, or rather pricing models, in relation to the services that you're creating based on prompts? Because at the end of the day, you're going to be charged tokens, right? So typically, when we define these types of services, we like charging fixed fees for standard SaaS models. That's a problem, because then you're carrying the fixed versus floating on your end, right? You're charging a fixed fee, but you're actually paying out tokens. There's a pretty simple solution to that, and it's that you actually keep track on a person-by-person basis of how much people are actually spending. And when you go and you implement something like this at a corporate level, then you are able to tell the corporate that you can cap, for example, usage in terms of spend at a user level. Now, obviously, that doesn't sound optimal if you're actually developing a solution, but it's extremely important if you're purchasing this software, if you're going through procurement, because people want to know what is their spend going to be. Unless you are a startup that wants to carry that risk of success, right? You're super successful because everybody's using your product, but you're actually charging too little, you're in trouble, right? This helps you deal with those problems. Next. Yeah, and the places where we've been implementing these types of workflows is actually quite varied. So everything from healthcare to government, finance. The ESG one is actually fantastic, because in the ESG space, unless you're dealing with very big companies that have processes to implement, let's say, MSCI-linked data capture processes, then a lot of the information that you're validating sits in policies. So it's very, very word heavy. And what we're doing is effectively taking all those policies, we're transforming unstructured data to structured data, which then means that we can actually create what the bigger companies do, which is all of these different scoring methodologies and so forth. We've been dealing with use cases where you, for example, have a supply chain where the buyer wants to ensure that the policies of the people that they're buying from are actually compatible with their own policies. We're not talking about making sure that they're actually following the policy. We're just making sure that the policies at least are compatible. Now, that's a fantastic thing to use with LLMs, especially if you have sequences of prompts that check specific things. You don't want to ask it, is this policy compliant? You're going to be having specific questions that you're asking yourself, like, for example, does this policy have X, Y, and Z criteria? Each X, Y, and Z are going to be separate sub-prompts. And at the end of that execution, then you have a pretty high integrity data set that just checks if the people are doing what they're supposed to be doing in terms of documentation. Next. Yeah, so we also do a lot of community engagement. So the gentleman standing right there, Mr. Mark, is very good at creating a lot of these videos and explanations about how you think about AI and how you actually contextualize it and how you use SIKE to solve these different problems. Because bear in mind that SIKE is supposed to be a platform for people to jump on and help you solve problems for others. So many consultants use the tools that we have here. And these are a fantastic set of videos that explain how you can actually start monetizing that skill set with your own customers if you are consultants, or if you just want to get into this space.